The next thing we're going to talk about are more properties of logs. So hopefully, again, you remember these from last year. Anytime you have two logs added together, that turns into multiplication. Anytime you have two logs subtracted, that turns into division. And anytime you have a log to a power, that power gets kicked out in front. So the way I like to remember this is if you take a plus sign and tip it over a little bit, if you rotate it 90 degrees to the right, it'd be at X. The minus sign looks like the division bar. Those are the same operation. And then your powers get kicked out in front. We'll talk about this change of base formula in a second, but again, that's something you should remember from last year. So to write each expression as a single log, the first thing you want to do is put the powers back on. So make it natural log of 5 cubed plus natural log of 6 minus natural log of 2. So if you want to, you could simplify that to 125. It's not necessary. You'll do it eventually, but you don't have to do it right now. And then the plus turns into multiplication. So 125 times 6. And then the minus turns into division. Now, you just want to write this, as the problem says, as a single log. So it's not natural log of this quantity divided by natural log of 2. It's just the numbers that get divided. This is a very common mistake. So when it says single log, you just want the word log written one time. So only divide or multiply the numbers. So you could reduce this if you want, and make that a 3 and this a 1, so it would turn into natural log of 375, and that's the way that you will leave that one. For our next example, we're going to go backwards, and it says to expand these logarithms. So hopefully you remember that the square root is the same as the 1/2 power. And so since we have a power, that gets kicked out in front. So you'd have 1/2 log of x squared minus 4. And even though there's a minus in here, you cannot turn that into division because it's only these quantities that are subtracted, not two logs that are subtracted. So this is as far as you can go on this problem. Example 8 is similar. You're just going to take that power and kick it out in front. And you may want to put it in parentheses. So you'd have x minus 1 times natural log of 6. Example 9 is a little bit more complicated. You want to start with the big picture, which is this division bar. So division turns into subtraction. So you'd have log of x cubed y squared minus log of z to the 4th w. And then each of these things are being multiplied. So we can change that into addition. So log of x cubed plus log of y squared, and minus, and you might want to put these in parentheses, log of z to the 4th plus log of w. And then the last but not least, we'll kick those powers out in front. So 3 log x plus 2 log y minus 4 log z minus log of w if we remove all of those parentheses. So the last formula that we didn't really talk about is the change of base formula, and this is what allows you to type something into the calculator. So you can change it to the common log, which is log base 10, which allows you to type it in your calculator. Or you could do natural log, which is log base e. Or really, you could change it into any base that you wanted to, so any log base a. So if you are asked to evaluate log base 6 of 21, simply type in your calculator log 21, and when you type in log in your calculator, it automatically opens a parenthesis, so you must close it before you do divided by log of 6. If you close this one, that's okay, but you must close this one after the 21. And so when I typed that in, I got approximately 1.7.